Assalamualaikum warahmatullahi wabarakatuh and a very good day to all of you. My name is Ahmad Iqbal bin Ibrahim and my MATList number is 208198. So today, I will present to all of you about the application of complex function on AC circuits. So let's go. So before we go into further into this topic, so let's start with the basic. In the young age, we were taught by our parents, by the teachers, to count positive numbers such as 1, 2, 3, 10, 100, 1000, and so on. And later in primary school, we were taught by our teachers to calculate and count negative integers such as negative 1, negative 2, negative 10, negative 99, negative 100, and so on and so forth. So, by this level, I assume that all of you are very familiar with this symbol. What is it? Yes, it is square root symbol. So, we commonly thought that we cannot take the square root of the negative numbers. But what if we could? Alright, now some of you must be wondering, how is it possible to take the square root of a negative number? In fact, the mathematicians back then before in the 16th century have thought this problem as well. So they gather together and say, "Hey bro, do you have any solution to this negative square root numbers?" Yes, they go together and they make halaqah and they discuss together lah, right? Right. So until then, this one ultimate savage mathematician from Italy named Girolamo Cardano. Remember his name? Girolamo Cardano, who broke the convention by inventing the imaginary numbers. So, in a desperate to attempt to solve a cubic equation, so this guy Girolamo Cardano solved this negative square root problem by inventing the imaginary number. Alright, now we know that AC circuit is one of the application of the complex function. So, how do they use this complex function equations or basics in the AC circuit? Alright, so this is the fun part. So, these complex function or complex numbers are also utilized in the calculation of first, current, second, voltage, and the third one is the resistance in the AC circuit itself. So, a common application of complex numbers, which is more specifically taken from the Euler's formula, is to compute the potential difference across two AC power supplies with respect to time. Yes, to compute the potential difference across two AC power supplies with respect to time. So maybe you wondering like, Aiman, no, I cannot understand. What are you saying? Can you give us picture? They where is the Raja? Where is the diagram? Where is the graph? Alright, chill. Now I present to you the pictures and the calculations. Alright. So as all of you can see here, this is one of the example to make such the calculation of two AC power supplies with respect to time to calculate the potential difference. So, if we want to find the potential difference, simply adding the VA and VB together will not work. But however, we can express both voltages as the real part, which is the x coordinate on the Argand diagram of a complex number. So, as you can see here, this is one of the example of the Argand diagram. As you can see here, the real axis is the x-axis, while the imaginary axis, which is labeled as I, or we usually saw it as the x and y. Now we need to see this Argand diagram as x real axis and I as imaginary number. Alright, so let this equation compute itself by applying this formula, and then we can add the complex number and then factorize and so on and so forth, and hence we will get the result, the full result of the V total, the potential difference between the two AC power circuit. Alright, after we done discussing about the potential difference in the AC circuit, are we done in this topic? Not quite yet, just a little bit more. So, complex numbers are also used to express the magnitude and the phase of impedance in the AC circuit itself. So, what is impedance? I know that most of you familiar with this impedance word. So, but what does it actually do in the AC circuit? It slows down the electrons in the circuit. The distinction is that impedance causes a phase to shift on the electrical circuit, but the resistance does not do that. Impedance takes in a common electrical component such as inductors and capacitors. Hence, having a complex numbers representation is crucial in this AC circuit analysis. So, in conclusion, complex numbers, complex functions serve as a representative of a phase, which is very essential in analyzing the AC circuit. So now, before I end my video, I have one question to ask to all of you. Who says that mathematics does not give us any reason to live?